Hello. Let's get started here with the notes for 3.3. Okay. All right. Postulate. We'll start with postulate 3.31. Converse of the corresponding angles postulate. Now, converse just means flip it around. We had the corresponding angles postulate that said if the lines are parallel, then corresponding angles are congruent. Well, if we flip that around, make it the converse, it's just backwards. If corresponding angles are congruent, then the lines are parallel. The theorem reads, if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So if, put an if right here, if angle 1 and angle 2 are congruent, then line M is parallel to line N. So basically it's repeating what we already know, just in a different order. Well, with that said, example 1b, using the converse of the corresponding angles postulate. So using that postulate we just mentioned. It says use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. Now, please. Sorry. So, we're talking about angle 3. I'll go over here and find it. The measure of angle 3. And right here is the measure of angle 7. Angle 7's right there. And you can tell they're corresponding. So that would mean that 4x minus 80 equals 3x minus 50. Well, let's solve that. If I subtract 3x from both sides, that gives me x minus 80 equals, this is gone, negative 50. Then I can finish that by adding 80 to each side. And look what I get. X equals 30. And that's what it says right here. So that's the same answer. So I've just shown by using algebra that those two lines are parallel. Not only do we have the corresponding angles converse, but we also have the converse of the alternate interior angles theorem and the converse of the alternate exterior angles theorem, and finally the converse of the same side interiors theorem. Again, we're just saying these backwards. Well, the next slide, last slide, a little bit of a proof. We're going to prove something, kind of like we're a lawyer. Proving lines are parallel. Well, notice what we're given. This is my directions. We're given that line P is parallel to line R. Let's highlight those in red. Right here's line P. Right here's line R. Those are parallel. So I'm going to make that like step 1. P is parallel to R. That's my given information. Well, step 2, wouldn't that mean that angle 2 and angle 3 would be congruent? Let's write that down. Angle 2 would be congruent to angle 3. Why is that? Because they're what kind of angles? Alternate exterior. Then it says, or then I'm going to put angle 1 is congruent to angle 3. Why is that? It's right here. That's given to me. Given to me in the directions. Well, if you look at steps 2 and step 3, here's the tricky part. Look at step 2 and step 3. It says 2 is equal to 3 and 1 is equal to 3. Well, can't you conclude that if 2 equals 3 and 1 equals 3, then angle 1 is congruent to angle 2? Again, let me repeat that. If 2 equals 3 and 1 equals 3, then 1 and 2 have to be congruent to each other. So 1 and 2 would be congruent to each other. That would make the lines parallel. That would make this line and this line parallel, because, kind of tilt your head sideways, angle 1 and angle 2 would be corresponding angles. So that would be the converse of the corresponding angles postulate. We'll talk more about this in class. Thanks for watching.